Okay, so for today we are going to study about the composite functions and inverse of the functions. So inshallah we are going to try to finish the composite and inverse of a function today. So after these lessons, I expect most of the students are able to find the inverse of a function and a compensation of a function. Okay. Okay, so first of all, yeah, let's have uh, the review about the previous lesson. Yeah. So if in the previous lesson we have studied about the domain, the range of functions, but then what if we are going to solve the questions regard to functions like this? Yeah, we are given the function of f of 2x minus 1 equals to 4x plus 5. Then what is the value of f of 5? Yeah. So if you are dealing with the question like this, usually we have fx, yeah, equals to something. Yeah, this is what you usually have. Yeah. But in this case, you have f of 2x minus 1. Yeah. So it is not f of x. Yeah. But here the f is in term of 2x minus 1. Yeah, and it is equals to 4x plus 5. So the question asks, what is the value of f of 5? F of 5, sorry. So f of 5, yeah, or f5, yeah. So we are going to do something here, yeah, so that we can get how much is f of 5, yeah. So we are going to make 2x plus 1 into 5. Yeah, it is equals 5. Yeah. So what value of x? Yeah, that satisfied to this. Yeah. So we are solving for x here. So we will get 2x equals to 5 minus 1, which is 4. And therefore we will get x equals to 4 divided by 2. So it is 2. Right. So to make, yeah, f of 2x minus 1 become f of 5, then we need to change x here into 2. Yeah. So this is what we are going to do. Oh, wait a minute. Oh, sorry. Here it is there is slight mistakes here. Sorry for that. It should be minus here. Remember, it should be minus because our question is minus. I don't know why suddenly it comes to plus. Yeah, sorry for these mistakes. Okay, so we are going to revise it. It should be minus here. Minus 1 equals 5. And therefore we have 2x equals to 5 plus 1. Yeah, so it is equal 6. And therefore x is equal to 6 divided by 2. So it is 3. Yeah. So sorry for the mistakes here. So it is 3. Yeah. Right. So to make here f of 2x minus 1, yeah, become f of 5, then we need to change this x into 3. Okay, and therefore we are substituting, yeah, 4, yeah, times 3. Yeah, we are change x into 3, and then plus 5, and therefore we will get this is 12 plus 5, and it is equals to 17. Yeah. Right. So this is about the functions. Yeah, we are changing the terms of functions. Yeah. So from if we are given functions, yeah, of 2x minus 1, and we are going to find f of 5, then we need to find the value of x, yeah, that satisfied 2x minus 1 equals 5. Yeah, so after we get the value of x, then we are substituting this, yeah, to the x here, yeah, because we already get, yeah, that to get f of 5, then we need to change x into 3. So after we are solving, so we got this equals to 17. Okay, do you have any questions about this one? No, yeah, so I can see some of students are turning their head. Okay, so now we are moving on to our lesson today. Yeah, so please open the camera. Yeah, so if you are not opening, I will send to the waiting room. Yeah, except for Dina, she is already asking the permissions. Right, then we are moving on the compositions here of the functions. Most functions that we meet can be described as combinations of two or more functions. So we are talking about the combinations of functions. Yeah, so later on we will say this as a compositions. Yeah. Okay, so for example, if we have the functions, yeah, of x, yeah, in terms of x, yeah, of 3x minus 7, okay, then these functions, yeah, is the function multiplied by 3 and then subtract by 7. Yes. Okay. So this function is the function of multiply by 3, then subtract by 7. Yeah. It is a combination of the two functions, g and f, where g is 3x and f is x minus 7. Okay. So we have two operators here. First, this function here is multiplied by 3. The second one is subtracting by 7. Yeah, subtract 7. Yeah, and therefore, if we are writing into the diagram, so we have x. First, we are map this x into the function of g, which means we are multiplying by 3. Then we are map this to the function of f, which is subtract 7. Yeah, so the functions of 3x minus 7 can be described as the function first do g and then do 5. Yeah, sorry, do f. Yeah, and this is what we call as the composition of functions. So maybe we are going to see the examples here, but to make you more understand, to give you more understanding about the composite of functions. So we are going to study the case here. So there is the cases here. So for this case, we have the answer from the 3 students. Yeah, we are given two functions. The first one is f of x, 2x minus 5, and then we have g of x, 3x minus 1. Yeah, these 3 students are going to find the composite function of g f x. Yeah, so look at the student A and then look at the student B and then look at the student C. Yeah, so which one is the correct process of finding this? Yeah, this is what we are going to look at. So take a look at this answer from student A. The student A find the composition of g f x by multiplying the function of g, which is 3x minus 1, by fx, which is 2x minus 5. Yeah, so the student A do multiplying. Yeah, and the student B, yeah, is inserting the function of f into the function of g. Yeah, inserting g into f. Yeah, means we are going to change x, yeah, in fx, yeah, with this one, 3x minus 1. So changing x to 3x minus 1, and therefore the student B got this answer. While the student C is doing the vice versa. Yeah, the student C substituting, yeah, the function of f into g. Yeah, she's doing vice versa. Yeah, from student B. So in putting, yeah, this students inputs f of x to gx, means she's changing x here with 2x minus 5, and therefore she got this answer. Okay, ladies, can you please give me the chat box? Which students give the correct answer? Yeah, which one is the correct one? Is it student A, student B, or student C? Okay, student, can you please do this in 1 minute? Give me the response. What do you think? Is it a student A, student B, or student C? Okay, I got from this Kamabrura. Still waiting? Come on. Please give the answer. Okay, maybe A. All right, so the students come up with different answer. Yeah, student A, and then student B, and then student C. But I can see that already 2 students, yeah, give the same answer. Okay, students, 15 more seconds. I'm still give you the times for the brainstorming. Now, 2 students choose A, 2 students choose B, 2 students choose C. Yeah, 3 students choose C now. Okay, so in conclusions, yeah, I can get the votes here. Let me give you the votes. For student C, there are 3 votes. Student B, 2, and student A, 2 votes. Yeah. Okay. So let's now we discuss, yeah, which one is actually give the correct solutions, yeah. When we are going to find the composition of functions g, yeah, fx, yeah, so here means we are going to find the composition of g fx, means we are going to insert f into g. Remember that. Yeah, we are going to insert f into g. Okay, later on we will see g is the outer functions and f as the inner. Yeah, if it is like this. But if we have f gx, yeah, sometimes the book say f o g x, o for compositions, yeah, this is g o f, like this, yeah. So means, yeah, f here, yeah, is the outer, the position of f is in the outer, and g is the inner. Okay, okay, different positions of f and g means a different meaning. Okay, in this case, in our explorations here, yeah, we are going to find g f x, means we are going to substituting f into g. Yeah, f. So how to do this? Yeah, first we are going to substitute f into g. So g, yeah, f, our f is like this. Yeah, this is how we do, like this. We are going to change x, yeah, in the g with f. Okay, so g is 3, yeah, and then x here become fx, yeah, minus 1. So this is what means by input or inserting or substituting or changing. Yeah, they're the same. Yeah. So we are changing, yeah, because g of fx. So we are changing x in the function of g with fx, yeah, f of x. Therefore, we'll get 3 multiplied by fx, yeah, which is 2x minus 5 minus 1. And therefore, we will get 6x, this is minus 15, and then minus 1 is minus 16. And therefore, the correct answer is the student C. Yeah. All right. So the student C also got the more votes. Yeah. So inshallah, there will be more students who can solve the questions of compositions. Right. Students, I will give you one more example. This is from the textbooks. Yeah. Exercise 2. Yeah. I will solve question number 1, and please solve the rest of the question for your treatment. Yeah. All right. So let's do this. First, we have f, yeah, is a quadratic, and then we have g is radicals, yeah, functions. Now we are going to find f of g6. Yeah. Remember, here f is the outer and g is the inner. So we need to do the inner first. Yeah, the inner here is gx. Yeah, right. So the inner is the function of g. So we are finding the inner first, g6. Yeah, g6. So you are substituting 6 into the function of g. So you will get square root of 6 plus 3, yeah, minus 2. So square root of 6 plus 3 means square root of 9. It is 3. 3 minus 1 is 1. Like this, right? After you find the inner functions, now you find the outer. Yeah. So f of g6 is f1 because g6 is 1, right? So you are changing x in the function of f of x with 1. So 1 square plus 6. So it is 7. Yeah. Right. So let's now we take a look at number B. First, look at the inner. The inner here is F4. So find the inner first, F4. So we are substituting 4 into the function of F. So we will get 4 squared plus 6. Yeah, 4 squared plus 6. So it is equals to 22, isn't it? 4 squared is 16 plus 6 is 22, right? Then we are substituting, yeah, f of 4 to g, right? So it will be g. So f of 4 is 22, so g 22. So g 22 is, we are changing the x in the function of g with 22. So square root of 22 plus 3, which is 25, minus 2. Square root of 25 minus 2 is 5 minus 2. So it is 3. Yeah. From these two solutions, yeah, we will see that f of g, yeah, it's not the same as g of x. This one, yeah. There is the properties here, yeah. F gx does not equal to g of fx, yeah. F gx does not equal to g fx, yeah. So it doesn't satisfy the commutative law, yeah. Okay, even if the number is the same, yeah. For example, if I'm changing 4 into 6, yeah, there will be a difference, yeah, answer. Okay, and then let's have a look at question number C. Yeah. F of f minus 3. Okay, there is a question here. Miss 22 come from? Where is 22 come from? 22 comes from, so look at this here. If we are finding the composition of a function, firstly, we need to do the inner. Remember, the inner is inside, the inside function. So the inner here is f of 4. Okay, f of 4. So means we are changing x in the function of f with 4. Okay, we are changing x in the function of f with 4. So x squared plus 6 become 4 squared plus 6. Okay, the square of 4 is 16. 16 plus 6 is 22. Are you okay, Rizka? Can you please give me thumbs up? Are you okay? All right, good. I can see your thumbs up. If you have any more questions, you can just ask, or you can just drop your question in the chat box. Okay, I will continue. What if we are doing the composition of a function with the same function? Let number C, a function of f to the function of f. Yeah, yes, we can actually do that. So the inner function here is f minus 3. So let's find the inner function first. So f minus 3, yeah, or f negative 3 equals to, we are changing the x in the function of f with negative 3. So it is negative 3 squared plus 6, right? So negative 3 squared is 9. 9 plus 6 is 15, right? So after that, we are finding the outer. The outer is f of f minus 3. So means it is f 15, because we already got the inners. F of negative 3 is 15. So f of 15 is, we are changing the x in the function of f with 15. So it is equals to 15 squared plus 6. Yeah, 15 squared is 225 plus 6. So it is 231. Yeah, 231. Are you okay with this? Are you okay with this? Right? All right. So students, because we are starting the lesson late today, because of the morning meeting, so I would like to ask your permission for taking your break times yet. Are you okay with this? Because I have one more question that I need to show you the process. Can you give me the thumbs up? But if you want to go somewhere, to the restroom, for example, you may leave, but give me the notif, yeah. Okay. I will solve one more example here. Actually, we have two more. So this is the exam mode, yeah. The third examples will be the is model questions. Yeah, it is multiple choice. Yeah, right, multiple choice. Okay, so let's me try to solve the second example. This is taken from question number 8 in your exercise. Yeah, 2.2. Yeah, question number 8. Yeah. So we are given the function of f. Yeah, which is this is a half of x plus 1, and then the function of g, which is a rational function. Yeah, this is a rational function because we have denominators in term of x. Yeah, so it is the rational. This one is a linear, yeah, a half of x plus 1, yeah, a polynomial, yeah, but this is the rational. Okay, note here that x must not equals to 1. Yes, because in rational, we are not allowed to have the denominator 0. Yeah, we have the condition here, and therefore we always define x, yeah, the denominator must not equal to 0, and therefore x must not equals to 1. Okay. So here we are going to solve the equation of g f of x. Yeah, means it is compositions. Yeah, solve the equation of g f of x if it is equals to 1. Okay, right, students. G of fx. So means we are going to insert the function of f into the function of g. Are you okay with this? Yeah. Remember, f is the inner, g is the outer. So we are going to insert the function of f into the function of g. Yeah. Right. So the function of f is this one. Yeah. And g is this one. So we are going to do substituting now. We are going to substitute f here to this. So it becomes 2f x, 2f of x, because changing x into fx, plus 3 over f x minus 1. Are you okay with this? Okay, right. Slowly but sure, So we are substituting, f into the function of g. So means we are changing x in g with f x, with f of x. Okay, so now we are continue. So 2 times, so the function of fx is x plus 1 over 2. So I will give the different colors then. Different colors better. Okay, so x plus 1 over 2. Okay, and then plus 3 over x plus 1 over 2, then minus 1. Okay, like this. So just simplify and solve. So we can do ketepak, ketepuk, right? Okay, so x plus 1 plus 3. So it is equals to x plus 4. So over, so here negative 1 multiplied by 2 is negative 2 plus x plus 1. So x plus 1 minus 2 over 2. And here we will get 2 times x plus 4 over x minus 1. Okay. Now we see that this is g of f of x. Okay. And it is equals to 1 according to this. Because it is equals to 1, so I will just directly write here, it is equals 1. Right, equals 1. And then I will change this to like this. Okay, so now we are going to solve this. Because the question asks to solve, find the value of x. Okay, solving this, we will get 2x plus 8 equals, we cross multiply x minus 1. And therefore here we will get x, 2x minus x is x equals to minus 1, negative 1 minus 8, or it is negative 9. So we will get that g of f of x is equals to negative 9. Okay. Right. Is there any more questions here? No. If there is not, so we are moving to the is model question. Is model questions, right? Is model questions. Given that f of x equals to x squared minus 2, gx equals to 2x plus 5. find the expression of fgx. Look, fgx means we are going to insert the function of g into f. G into f means we are going to change x in the function of f with gx. So we'll get gx square, because it is x square, minus 2, right? And therefore, yeah, gx is 2x plus 5. And the square, and we are taking the square of this, and then subtract with 2. Yeah, in this case, you will check the answer, which one is satisfying. So it will be the option B. Yeah, so the answer is B. Okay. Right, students, do you have any questions about this one?
Miss,
Yes.
may you repeat why it becomes g of x square?
G of, okay, sure.
May you please?
Okay, I will repeat. Yeah. First of all, yeah, here the question asks the expression of f gx. Remember, f gx means f is the outer, g is the inner. Yeah, in compositions, yeah, if the inner function is the insert function, so we are going to insert g into f, and therefore we write f of gx. Okay, we are going to insert this into this, insert. Yeah, that's what it means. Yeah, because it is inner. Yeah, so inserting gx into fx, and therefore we are changing x here with gx. Okay, because this is x squared, then become g of x squared, and g of x is 2x plus 5, and therefore it will be the square of 2x plus 5 minus 2. Yeah, because it is minus 2. Right. Can you give me your thumbs up if you understand? Yeah, I will share the recording of this lesson in the announcements group. Yeah, so that you can rewind again. Okay. Right, ladies, I will stop share and then take the attendance of yours. Yeah. So please come back to the Zoom. Yeah, I will close this Zoom and then please you come back again. Yeah, there will be no break times. Yeah. All right. See you, ladies.